Hello, CRV 2020. I hope you are all safe and doing well during these challenging times. My name is Rahul Dass, and I'm a PhD student studying computer science at the University of Miami. On behalf of my co-authors, it is my pleasure to present our paper titled "It's Not Just Black and White, Classifying Defendant Mugshots Based on the Multidimensionality of Race and Ethnicity." A little context to motivate the problem. Here are some images, and I'm wondering if you see what is common amongst them. Well, they're all women, they're people of color, but they've been identified as being either male or no face at all. With the rise of fields in machine learning, such as fairness, accountability, and transparency, these images are a few examples of racial and gender bias from three impactful auditing papers evaluating commercial facial recognition technologies that have consequently led some of those companies to release updated APIs for their systems. This has further inspired the vision community to develop new and more inclusive benchmark datasets, particularly for race and gender. Recent efforts to pinpoint the bias issue, whether it be the model, the API, the dataset used for training, or something else that we do not yet know, has led researchers to investigate whether relationships between sensitive physical attributes and demographic groups exist or not. With Miami being our home for the past few years, we've identified a lack of research regarding Hispanic face classification across various research communities. We came across 13 papers from the vision community in particular that investigated facial attribute classification, including race, where a face was always seen to belong to one of several subcategories, including white, black, Hispanic, Indian, etc. Inspired by the work done in critical race theory, substantiated by studies in sociology, we find that race should not be considered simply as a singular defining attribute, but rather as a multidimensional construct. For example, within the US, people choose to identify themselves as Black and Hispanic. With that in mind, our paper aims to address the following research questions. Considering the task of deep learning-based image classification and focusing on the labeling component within the deep learning pipeline, how would deep learning models' performance vary if the task changed from race to race ethnicity classification? With many novel deep learning architectures being proposed so frequently, it was a non-trivial task for us to determine which off-the-shelf model would perform well or the best for our given task. And therefore, is there a relationship between model architecture and performance? Lastly, given our use of a novel face data set, which we will introduce in the next slide, we wanted to compare the effect of training deep learning models using the same input data set, but annotated by different sources, namely a single actor versus multiple raters for an image. The data we use contain 194,000 arrestee mugshots and were obtained from the Miami-Dade County Clerk of Court offices. Now, we'd like to point out that while mugshots and arrest records are publicly available data, we obtained the data with IRB approval from the University of Miami, and additional steps were taken to protect individuals' identity. For more details, please refer to our paper. Now, you may be wondering why Miami-Dade County? Well, MDC is an ideal location to gather Hispanic data, as we can see from Table 1 when comparing the overall demographic spread with the entire US in general. Moreover, Table 1 also shows us a clear overrepresentation of Black Hispanic and Black non-Hispanic when considering their respective demographic spread within the general Miami-Dade population. Thus, we greatly believe that race ethnicity identification is a key component within the US criminal justice system. And based on our findings, we are encouraged to further analyze and hopefully prevent racial ethnic bias within the MDC criminal justice system for future research. To obtain multiple rater annotations, a group of demographically diverse University of Miami sociology students rated a stratified sample of 14,000 mugshots and provided 29 annotations, including 2 race, black and white, and 4 race ethnicity, black, Hispanic, black non-Hispanic, and white non-Hispanic. While an arrestee is identified by their race, ethnicity is not mentioned in court records. There have been several studies within the socio-criminology literature of using a surnames text-based approach in identifying an arrestee as Hispanic if their surname is found within the US Census Hispanic surnames list. Thus, we are wondering if a deep learning-based image classification approach could lead to more accurate race ethnicity classification based on mugshot data. During the experimental stages using the FastAI PyTorch libraries, we developed various models based on 7 model architectures and used transfer learning based on ImageNet weights. The models were built by varying experimental parameters such as mugshot sample size, balanced versus imbalanced, balanced being 1,000 samples per race or race ethnicity category, the extent of image processing, for example, using raw images, as you can see on the right, compared to open face pre-processing, which is a tool that was used to detect and segment a face from the background to investigate model sensitivity to areas other than the face in an image. For illustration purposes, we should mention that actual mugshots of celebrities from our dataset have been used to avoid the invasion of privacy of the remaining defendants from 2010 to 15. The evaluation metric that was used was model accuracy. One of the more interesting deep learning hyperparameters that were experimented with was finding the optimal learning rate to train our models using an NLP-inspired technique called differential learning rates, which is a built-in functionality in the FastAI library. Lastly, our models were trained for 5 epochs, and then the layers were unfrozen to be retrainable for an additional 5 epochs and were then evaluated. And here are results. For binary race classification, when comparing the best models trained within the balanced open face setting, there was not much difference if we look at the best models between the courts or a single rater that achieved 94% compared to multiple raters or the students, which achieved 93%. While there was no single model that outperformed all others, when we compared the best balanced model within the open face preprocessing segment, so it would be VGG19 with batch normalization, and with the best imbalanced model that was ResNet 50, that was around 97% accuracy, the difference between the two was a gain of just 2.73% by annotating almost 100 times more data. Now here's where things get really interesting when we consider the results of race ethnicity classification. By looking at the overall results, we can see that the accuracies are much lower than the binary race classification, which suggests that race ethnicity is a more difficult and subjective task to distinguish. If we take an average of the open face balanced court data set, deep learning accuracies, we find that the models performed only slightly better than chance, around 56%, which is not helpful when predicting a class amongst 4 other categories. Deep learning models using mugshots that were annotated by a diverse demographic group of student raters consistently outperformed their court annotated counterparts by 12 to 22% in increase in accuracy, which is a significant finding. And thus, we are curious about the trade-off between a balanced sample size versus higher accuracies when using an imbalanced data set. For future work, we used ImageNet weights, which consists of 1,000 regular object categories, such as dog, cat, plane. And so we are curious if we were to develop these deep learning models from scratch, or models specifically that were trained with face weights, if that makes a difference in accuracy, such as VGG face, FaceNet, and other novel data sets that were created by the vision community. Established a new learning method for the social sciences community. And so in order to do so, we would use inference learning based on the best balanced student race ethnicity model and generate the remaining 190,000 deep learning based model race ethnicity labels, and then compare the performance with the imbalanced surnames text-based approach for the squeeze ResNet 50 model that obtained 81% accuracy. And finally, we would like to evaluate how biased each deep learning model is with respect to each race ethnicity subgroup and assess if the new methodology fosters deep learning models to be more demographically inclusive, as facial recognition technologies that are in use in society today affect the most underrepresented demographics. In conclusion, the novel multidimensional approach for understanding and annotating race in face datasets by looking at race ethnicity combinations was proposed. Our best model was able to obtain approximately 75% accuracy by using only 2% of the annotated dataset, by having a demographically diverse group of raters provide the annotations. We outperform court records that employs a single rater by 12 to 22%. And we would like to further investigate the implications in terms of court sentencing outcomes to suggest a new methodology for various interested communities, including the criminology and socio-legal communities. And we would like to move the literature forward. We hope that our work has moved the literature forward, in particular for Hispanics, and we hope that that our multidimensional approach for annotating race is working towards a more inclusive approach when building facial recognition and facial processing technologies. We would like to thank the University of Miami Laboratory for Integrative Knowledge, ULINK, for supporting our work. And in spite of COVID-19, we would also like to thank Dr. Paul and Dr. Brown for holding the CRV 2020 virtual conference. And if there are any questions, comments, or feedback, please feel free to contact me at rdas@cs.miami.edu. Thank you for this opportunity and your time.